Training a frontier model from scratch costs millions of dollars in raw compute. So what happens when you already have a great base model, but it simply doesn't know enough about medicine or law or a language it barely ever saw during training? You don't start over. You continue. Today we're breaking down continued pre-training, sometimes called domain adaptive pre-training, and how it lets you specialize a model on the cheap without throwing away everything it already learned. Let's frame the choice first, because the economics tell almost the whole story here. Your first option is to train a specialized model completely from scratch. You would gather a fresh corpus and then burn a small fortune in compute, spending millions of dollars to reach a strong base all over again. For most teams, that is simply out of reach, and it throws away every dollar and every bit of effort already spent on an existing, perfectly good model. Continued pre-training takes the other road entirely. You start from a model that already works, and you extend it with a relatively small amount of extra training on the specific domain you care about. All of that original investment carries straight forward, and you pay only for the thin layer of specialization you add on top. To see how this actually works, follow one base model through the method, one stage at a time. We start with a pre-trained base model. It already reads and reasons broadly across everything it saw during its original training run. Think of it as a very capable generalist that simply hasn't specialized in your particular target domain yet, whether that's medicine, law, or code. Then we keep going with next token training, but now on new domain data. Medical papers, legal text, code, a low-resource language, whatever it is you actually need. Crucially, this is the same self-supervised objective as pre-training, teaching genuinely new knowledge and vocabulary, not instruction pairs at all. At the same time, we mix in some of the original general data. This replay ratio, paired with a deliberately modest learning rate, is the main guardrail against catastrophic forgetting, where overtraining on the shiny new domain quietly erodes the model's hard-won broad abilities across everything else. And out the far end comes a domain-specialized base model. It carries fresh, deep knowledge of your field while keeping its general competence essentially intact. Very often you continue pre-train for knowledge like this first, then fine-tune afterward to teach the model how to follow instructions. There are really three ideas that carry this technique, and each one is worth keeping in mind. The core move is extending a base model with more pre-training, rather than starting fresh. You reuse absolutely everything the model already learned, all that broad world knowledge, and you simply add a focused round of extra training on top of it, targeted at the domain you actually care about. This injects domain knowledge cheaply and directly. Because it's still raw next token learning on plain text, it teaches genuinely new knowledge and vocabulary, which is quite different from fine-tuning on instruction and response pairs, which only shapes behavior. And you mix in general data to avoid forgetting. Blending some of the original data with a modest learning rate preserves the model's broad competence, even while it specializes hard on the brand new domain you care about. Okay, let's lock in the essentials. 4 of them worth keeping from all this. Continued pre-training extends an existing base model with more next token training on a new, targeted corpus of text. It reuses a costly pre-trained model instead of spending millions of dollars to train a specialized one from scratch. It teaches knowledge and vocabulary, not behavior, which is the key distinction from fine-tuning. So teams often continue pre-train first and then fine-tune later for instructions. Mix in general data to dodge catastrophic forgetting. If this kind of behind-the-scenes AI is your thing, Standarity.com has plenty more waiting. See you in the next one.